When using non-metallic sheathed cable, often called NM cable, in conduit for physical protection, understanding the National Electrical Code requirements for support is critical. According to the NEC, the conduit essentially acts as a support for the NM cable within it. Therefore, the last staple or securing means for the NM cable must be within 12 inches of where the cable enters the conduit. This is explicitly covered in NEC section 334.30b, which addresses NM cable installations in raceways. This section directs us to 334.30 for securing the cable to the raceway and 334.30c for support requirements. NEC section 334.30b states that NM cable shall be permitted to be installed in a raceway. In such installations, the cable shall be secured to the raceway in accordance with 334.30 above, and it shall be supported in accordance with 334.30c below. NEC section 334.30c provides the specifics on support. It mandates that non-metallic sheathed cable be supported in accordance with 300.11 and shall be secured to a surface by staples, straps, or similar fittings so designed and installed as not to injure the cable. Support shall be spaced at intervals not exceeding 1.8 meters, which is approximately 6 feet, and shall be permitted to be installed by placing the cable in a strap, staple, or similar fitting that is installed before the cable is laid in place. Lesser spacing shall be permitted where necessary to prevent damage to the cable. The intention is to ensure the cable is adequately supported to prevent strain on the conductors and terminations. It's important to clarify some common misconceptions. Firstly, the idea that the conduit must stop short of the box and be stapled before terminating is not entirely accurate in this context. While proper conduit installation is important, the focus here is on supporting the NM cable itself. The conduit is serving as a protective sleeve, and its termination should comply with general conduit installation practices, but the NM cable support rule still applies. Secondly, it is not sufficient to simply run the NM cable into the conduit without any support near the entry point. The NEC is clear that the cable needs to be secured within 12 inches of the conduit entrance. This ensures that the weight of the cable is not solely borne by the point where it enters the conduit, preventing potential damage. The proper way to sleeve NM cable for physical protection involves several key steps. 1. Determine the length of conduit needed to provide adequate protection for the cable run. 2. Select the appropriate size and type of conduit for the application. Consider factors like the environment and potential physical hazards. 3. Install the conduit according to standard practices, ensuring it is properly secured and terminated at both ends. 4. Before pulling the NM cable into the conduit, ensure that the last staple of support is within 12 inches of the conduit entrance. This may require adjusting the existing cable run or adding additional supports. 5. Carefully pull the NM cable through the conduit, avoiding any sharp bends or excessive force that could damage the cable. 6. Terminate the NM cable in the electrical box according to standard wiring practices, ensuring proper connections and strain relief. Now let's consider some practical examples. Imagine a scenario where you need to run NM cable along a basement wall where it is susceptible to physical damage. You decide to use a length of conduit to protect the cable. Before running the cable into the conduit, you would ensure that the last staple securing the NM cable to the wall is no more than 12 inches from the point where the cable will enter the conduit. This provides the necessary support and prevents the cable from sagging or being damaged at the entry point. Another scenario might involve running NM cable through a tight space, such as between floor joists. In this case, you might use shorter sections of conduit to protect the cable where it passes through particularly vulnerable areas. Again, the key is to ensure that the cable is properly supported within 12 inches of each conduit entrance. It's also important to consider the type of fittings used to terminate the conduit. Use fittings that are specifically designed for the type of conduit being used, and ensure that they are properly tightened to provide a secure and weatherproof connection. When installing conduit, always follow the manufacturer's instructions and any applicable local codes. In addition to the support requirements, it's also important to consider the full capacity of the conduit. The NEC specifies the maximum number of conductors or cables that can be installed in a given size of conduit. Exceeding this full capacity can lead to overheating and other problems. Refer to the appropriate NEC tables to determine the correct conduit size for your application. Furthermore, ensure that the NM cable is properly rated for the environment in which it is being installed. If the cable is exposed to moisture, chemicals, or extreme temperatures, use a cable that is specifically designed for those conditions. Using the wrong type of cable can create a safety hazard. Another important aspect of NM cable installation is proper grounding. The NEC requires that all metal enclosures, including conduit, be properly grounded to provide a safe path for fault current. This helps to prevent electrical shock and minimize the risk of fire. Make sure that the grounding system is properly installed and tested before energizing the circuit. Always use approved connectors and grounding clamps to ensure a reliable connection. When working with electrical wiring, always follow safe work practices. To energize the circuit before working on it, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electrical wiring, hire a qualified electrician to do the job. Electricity can be dangerous, and it's always better to be safe than sorry. In summary, when using NM cable and conduit for physical protection, remember these key points. Firstly, the conduit acts as a support for the NM cable. Secondly, the last staple or support must be within 12 inches of the conduit entrance, as per NEC 334.30b and 334.30c. Thirdly, always follow standard wiring practices and local codes. Fourthly, ensure proper grounding of all metal enclosures. Fifthly, use appropriate personal protective equipment and safe work practices. By following these guidelines, you can ensure a safe and professional NM cable installation. Consider the broader context of electrical safety. Electrical safety is paramount in any installation, and understanding the NEC is crucial for ensuring that installations are not only functional but also safe for occupants and the environment. The NEC is not just a set of rules, it is a comprehensive guide developed by experts to minimize electrical hazards. Regular updates to the code reflect advancements in technology and lessons learned from past incidents. Therefore, staying current with the latest edition of the NEC is essential for anyone involved in electrical work. Proper planning is also crucial for any electrical project. Before starting any work, carefully assess the load requirements, circuit capacity, and environmental conditions. This will help you to select the appropriate wiring methods, overcurrent protection devices, and other components. A well-planned installation is more likely to be safe and reliable. Furthermore, consider the impact of the installation on the overall electrical system. Make sure that the new circuits are properly balanced and that the existing system has sufficient capacity to handle the additional load. Overloading the electrical system can lead to voltage drops, overheating, and other problems. Regular maintenance is also important for ensuring the continued safety and reliability of electrical installations. Inspect wiring, connections, and overcurrent protection devices on a regular basis and address any problems promptly. Replace damaged or worn components and tighten loose connections. A proactive maintenance program can help to prevent electrical failures and extend the life of the installation. Education and training are also essential for promoting electrical safety. Provide employees with ongoing training on safe work practices, electrical hazards, and the proper use of tools and equipment. Encourage employees to report any safety concerns or potential hazards. A well-trained workforce is more likely to follow safe work practices and prevent accidents. Finally, remember that electrical safety is a shared responsibility. Everyone involved in the design, installation, operation, and maintenance of electrical systems has a role to play in ensuring that they are safe. By working together and following established safety guidelines, we can minimize the risk of electrical accidents and create a safer environment for everyone. The NEC provides specific guidelines for different types of wiring methods, including non-metallic sheathed cable, metal-clad cable, conduit, and underground wiring. Each wiring method has its own unique requirements for installation, support, and protection. It is important to select the appropriate wiring method for the specific application and to follow the NEC guidelines carefully. For example, when installing non-metallic sheathed cable, it is important to protect it from physical damage by running it through conduit or using gauze strips. When installing metal-clad cable, it is important to ensure that the armor is properly grounded. When installing conduit, it is important to use the correct type of fittings and supports. When installing underground wiring, it is important to bury it at the proper depth and to protect it from moisture and corrosion. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect wiring and equipment from overloads and short circuits. It is important to select the correct size and type of overcurrent protection device for each circuit. The NEC provides tables and formulas for calculating the ampacity of conductors and the interrupting rating of overcurrent protection devices. It is also important to ensure that overcurrent protection devices are properly installed and maintained. They should be tested regularly to ensure that they are functioning properly. Grounding is another essential element of electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to trip overcurrent protection devices and prevent electrical shock. The NEC requires that all metal enclosures, such as electrical boxes and conduit, be properly grounded. It also requires that all electrical equipment, such as appliances and motors, be grounded. Grounding electrodes, such as ground rods and water pipes, are used to connect the grounding system to the earth. It is important to ensure that the grounding system is properly installed and maintained. The connection should be tight and corrosion-free. Surge protection is also becoming increasingly important in modern electrical systems. Surges are transient overvoltages that can damage sensitive electronic equipment. Surge protection devices, such as surge suppressors, are designed to divert surge current away from the equipment and back to the source. Surge protection devices should be installed at the service entrance and at branch circuits that serve sensitive electronic equipment. Electrical inspections are an important part of ensuring electrical safety. Electrical inspectors review electrical installations to ensure that they comply with the NEC and other applicable codes. They identify any deficiencies and require that they be corrected. Electrical inspections are typically required for new construction, renovations, and additions. It is important to cooperate with electrical inspectors and to correct any deficiencies promptly. In addition to the NEC, there are other standards and regulations that govern electrical safety. These include standards developed by organizations such as the Institute of Electrical and Electronics Engineers, the National Fire Protection Association, and Underwriters Laboratories. These standards provide guidance on a wide range of electrical safety topics such as grounding, wiring, and equipment safety. It is important to be familiar with these standards and to follow them when designing, installing, and maintaining electrical systems. Finally, it is important to remember that electrical safety is an ongoing process. It requires constant vigilance and a commitment to following safe work practices. By staying informed, following the NEC and other applicable standards, and working together, we can minimize the risk of electrical accidents and create a safer environment for everyone.